we have a new derivative here. So the derivative with respect to x of the natural log of x is just 1 over x. Okay. And we can now actually prove this using the chain rule. Let me just write something here. So from the chain rule, if we were to differentiate e to the f of x for now, this would look like, well, e to the f of x. That would be the derivative of the outside. And the inner function is this f of x. So if you differentiate it, you have times f prime of x. And now you might be wondering, what on earth does this have to do with the natural log? Well, if we let f of x equal the natural log of x, this might be helpful. So let f of x equal the natural log of x. Okay. If we do that, then is what we end up with here is d dx of, and actually I'll write this in here, e to the natural log of x, which this is just going to be x here in a second, right? E to the natural log of x is just x. And then again, e to the f of x here is just e to the natural log of x. And we have this f prime of x here, which we don't know yet. Well, we kind of know it, but we're pretending like we don't know this yet, okay? Now, let's take this a step further. Well, this should then just become the derivative of x. And this should just become times x times f prime of x. And let's go another step further. Well, the derivative of x with respect to x is just 1. And note, the thing that we were trying to figure out is what f prime of x is equal to. Why don't we just solve for it? So if we do that, we'll get f prime of x is equal to 1 of x, or 1 over x. All right, and so now we can use this without going through this process. The derivative of the natural log of x is just 1 over x. Now we're going to add a couple more derivatives to our list here. The next one is just log base a of x. What's its derivative? Let's write down what its derivative is. So if we were to take the derivative of this, it should just be 1 over x times the natural log of a. And this looks actually a lot like the derivative of the natural log of x, other than this natural log of a down here. And the reason that these look a lot alike is we can always rewrite log base of some number in terms of any other base. Okay. And here's what I mean. If we were to start off by looking at the derivative of log base a of x, we can rewrite this. Okay? We can rewrite it using what we call the change of base formula. And so when I use the change of base formula, I'm going to end up with the natural log of x on top and the natural log of a in the denominator. Let's maybe write what formula we use there. Now, the natural log of a is just a constant, so you can pull that out, 1 over the natural log of a, right? The a is the base here. And then we have the derivative with respect to x of the natural log of x. And we know that to be 1 over x, so you end up with 1 over the natural log of a times 1 over x. And this right here is equivalent to what we wrote up here, right? Okay, so we're done. And we're going to look at one last new derivative, and that is if we have an exponent, an exponential function that's not e to the x. So maybe 2 to the x, 3 to the x, 4 to the x, so on. Okay. Now, its derivative, let's see what it looks like. It's going to be a to the x times the natural log of a. Okay. And again, this looks a lot like the derivative of e to the x, other than we have this extra factor here. Okay. And let's see why. So if we were to start trying to find the derivative of a to the x, well, we're going to use a little trick here. We are going to take this a to the x and we are going to write it as e to the natural log of a to the x. Right? E and the natural log are each other's inverses, so e to the natural log of a to the x is just a to the x. So, looking good so far. We have a log property that says we can actually rewrite this a little bit. We can bring this x down in front of the natural log. So we have e to the x times the natural log of a. Okay, and it's looking good so far. Next, well, we can use the chain rule. Okay, the chain rule, we just learned it, right? So let me get a different color here. Our outer function is e to the x, and the inner function is x times the natural log of a. But now remember, the natural log of a is just a constant, so the derivative of g is actually, maybe I need to scoot over a little more. The derivative of g is just going to be that constant, the natural log of a. This is like if we were taking the derivative of 5x, right? We get 5. Well, it's just instead of 5, we have the natural log of a there. And if we were looking for f prime, I suppose we could find that too. That's just going to be e to the x again, right? So let's try and use the chain rule. So we should have the derivative of the outside, so that's the e to the x times the natural log of a. Then we can multiply by the derivative of the inside, which we found to be the natural log of a. And now that we're done differentiating, maybe we can rewrite this a little bit. This x, maybe I could bring it back in. So I have e to the natural log of a to the x times the natural log of a. And if we go one step further, we're done. E to the natural log of a to the x is just a to the x. So then we have times the natural log of a. Right, and so we have a few more examples that we're going to do here so that we can practice using these new derivatives. Again, the derivative of a to the x is equal to a to the x times the natural log of a. The derivative with respect to x of log base a of x is just 1 over x times the natural log of a. And the derivative of the natural log of x is just 1 over x. All right, so here is our first one. And again, you might find it helpful to write on the side here what f and g are. You don't have to, but f would be the natural log of x, and so then g of x, the inside function, is that x squared plus 1. Okay. Now, if we took the derivative of the outside function, that should look like 1 over x. Okay, and let me start writing this. Look like 1 over x if this was just the natural log of x, right? But we're supposed to do, right, f prime of g of x. And so instead of 1 over x here, we have 1 over x squared plus 1. All right, and then we want to multiply by the derivative of the inside function. So the derivative of g is just 2x. And all we can really do to make this look nicer is maybe write this as 2x over x squared plus 1. That's about it. Part B. So here we just need to remember that the derivative, maybe I should use a different function name. If you say have h of x and you're trying to differentiate a to the x, well then its derivative is equal to a to the x times the natural log of a. So that's the rule we're going to use here. And so I do have 5 to some function, it's not x, but we can start using this rule. The derivative of the outside function should be 5 to the cosine of x times the natural log of 5. Right? The base of this exponent was 5. That's where this is coming from. Now, we haven't taken the derivative of the inside function yet, which is cosine of x. And so if we take the derivative of cosine of x, we're going to get minus sine of x. So I'm going to just attach that here, times minus sine of x. And there's not really going to be a best way to write this. Maybe we'll put the minus natural log of 5 up front, since it's constant. And then we have times our 5 to the cosine of x and times sine of x. All right, and we have one last one. Log base 3 of the natural log of t. So if we were to take this derivative, we need to remember that, well, we're going to have 1 over whatever's in here, inside the logarithm, and it happens to be actually another logarithm. It's the natural log of t. And you're also supposed to have down here the natural log of the base. Now, to finish this, we need to take the derivative of the inside function. That was the derivative of the outside. The derivative of the inside will just be whatever the derivative of the natural log of t is, and that is 1 over t. And so if we try to write this a little bit cleaner, this is going to just look like 1 over the natural log of 3 times t times the natural log of t.